Okay, so these are special right triangles because when you cut a box in half, it makes a 45, 45, 90 right triangle. I cannot stress enough. This only works for triangles that have 45, 45, 90 degree angles. So if you don't see a 45, 45, and a 90 in there, this math will not work. Make sense? These triangles that are 45, 45, 90 are also isosceles triangles because they're half of a box. The kind of, right? On a box, all four sides are equal. So if I cut it in half, are these two side lengths going to change sizes? No. So here's kind of the whole math principle that's going to work out. If I give you a number on the leg, like 9, I'm going to ask you to solve for the other two pieces. So if this side is 9, how big does this side have to be? 9. And if the legs, these are the legs of the triangle because this is the hypotenuse. If the legs are 9, how long is the hypotenuse? Look at that. You just got all three sides of the triangle and you didn't even touch your calculator. Cool, right? There is only 2 rules to follow for this whole process. To get from a leg to a hypotenuse, we're actually multiplying by the square root of 2. Because the hypotenuse is bigger, so we have to multiply to make it get bigger. If we're going from the hypotenuse back to a leg, we are dividing by the square root of 2. This is the only math you're going to do today. Either times the square root of 2 or divided by the square root of 2. That's all we're doing. You just have to make sure you're doing the right process at the right time. So in your notes, I was like, hey, oh, we just did that one. Can I change it? Can we change it? How about a 7? It says, I want to find x and y. All right? Do we need any math to figure out how big x is? How big is x? 7. Because this leg will always equal this leg in a 45, 45, 90. Now, the mathematical process to get from a leg to a hypotenuse, do we multiply by the square root of 2 or do we divide by the square root of 2? Multiply. So this number times the square root of 2. I'm going to write that over here. What is 7 times the square root of 2? No decimals.
9. Or
Nope.
10.
Nope. Perfect. It is 7 times the square root of 2 is 7 square roots of 2. Stupid, right? Remember how we worked on this? We had 7 times the square root of 2. 7 times 1 is 7. 1 times 2 is 2. So I know it's the first time we've been talking about it. Whenever you do a whole number times a radical, they become together the whole number and the radical. Does that kind of make sense? So look, we have the whole triangle, and we didn't do a squared plus b squared equals c squared ever. These are special right triangles. It sucks because you have to do a lot of mental math, but you can still write it down. Right? So that's going from a leg to the hypotenuse. Let's go backwards. What if I have a hypotenuse and I want to get to the leg? This is one of those ones that's important that I need you to watch. Watch this one. How do I get from a hypotenuse back to the leg? I'm going to divide by the square root of 2. When you do that, 10 divided by the square root of 2. That is mathematically inappropriate. You are never allowed to do that. Why can't I do that? Because of the radical. You can never have a radical in the denominator. Ever. If you put that on your test, you're wrong. So how do you fix it? Yes, you multiply by 1. So you multiply by the most disgusting form of 1 you could ever think of. Ugh. Right? So I'm going to do 10 divided by the square root of 2 times 1. Now we just talked about this. Don't be goldfish. What is 10 times the square root of 2? 10 square roots of 2. Yes. Okay, maybe a little more complicated here. The square root of 2 times the square root of 2. So we're multiplying these numbers on the inside, which is the square root of 4. But what is the square root of 4? So the square root of 2 times the square root of 2 is 2. Let's see. All right. Now, after all of that, here we are. Still wrong. Because whole number, I can simplify that. What is 10 divided by 2? 5. Sucks, right? So, and you can check. Do I mess with this guy under the radical? No, because he's not under a radical. So that means this side is 5 square roots of 2. How big is this side? That's a lot of stuff, isn't it? As you start practicing this, you'll start to know that this is 10 square roots of 2, and this is 2. You can get to this, and then just simplify 10 over 2. Guys, we've done everything, right? This is all the new learning that's taking place. Now we're just having time to practice. So I need you guys to ask questions. Be like, Baker, I still don't get it, or can you help me figure this out? Let's try another one. What is that 24? Is that a hypotenuse or a leg? It is a hypotenuse. So how do I get from a hypotenuse to a leg? 24 divided by the square root of 2. Starting the process over. How much do you remember? Wrong, 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 wrong. Can't do that. Shame, shame. How do you fix it? Multiply it by the number 1. The most disgusting form of 1 you can think of. Throw up noise. Multiply across the top, 24 times the square root of 2. 24 square roots of 2. Multiply across the bottom, the square root of 2 times the square root of 2. 2. Can you do 24 divided by 2? What do you get? 12. And you still have a square root of 2 on top. Has anybody seen a pattern yet? No patterns? Let's just keep going until you see it. Yes. Kind of. You're right. There will always be a square root of 2. Cool? What kind of number is this? Where's the radical? So if the leg is a whole number, the hypotenuse will have the radical, or the square root of 2. So let's see if that pattern checks out. Well, the hypotenuse has a whole number, so does the leg have a radical? Yeah? So you're going to get a radical somewhere. If the hypotenuse is whole, the leg has a radical. Well, let's check the last one. Well, the hypotenuse is a whole number, and the leg has a radical. You said it's always going to be the square root of 2, right? What's 12 times 2? Sneaky, sneaky. What's 5 times 2?
10.
Oh, I see. Yeah, okay. But does that work here? Because the leg is a whole number, so I just kind of add the square root of 2 to the back side. There are tricks, but you have to make sure you do the right tricks in the right time. Okay, here we go. There's a 16 on the hypotenuse, so what should you expect to see on the leg? You should expect to see that what thing? There should be a square root of 2 here. And we just did the trick. I don't know, let's check and see if it is 8 square root of 2. Because 8 times 2 is 16, right? So let's try it. 16 divided by the square root of 2, multiplied by 1. It's a rationalized 1. So multiply this way. 16 times the square root of 2, 16 square roots of 2. The square root of 2 times the square root of 2 is 2. And 16 divided by 2 is 8. Yay, it worked. So you can take the long way, you can take the short way, doesn't really matter. We're going to use this from now until the end of the year. That's why we're going so slow. Is it clicking for anybody? You like it? You hate it? You like it? Because you don't have to use your calculator? Okay. This side's 7. How big is this side? 7. And how do we get from a leg to the hypotenuse? It's going to get bigger, so we multiply by the square root of 2. So what is 7 times the square root of 2? Boom, you're done. So as long as you guys realize we're only doing two processes today. Either multiplied by the square root of 2 or divided by the square root of 2. Which one do you think is easier, multiplying or dividing? Multiplying? Okay, so if you like multiplying, let's go with some multiplication now. All right? These aren't in your notes. They're not in your notes, so I just kind of want you guys to watch. So if there's a 3 right here, what goes right here? And how do you get from here to here? Multiply. So what's the answer going to be? Too much? Too fast? 3 times the square root of 2 is... Can I see a pattern? Okay, let's try another one. 19. How big is this guy going to be? Yeah? We good? Feeling it? Feeling the love? Well, let's try a hard one. Can we do a hard one? Okay, if this side is smiley face, how long is this side? Smiley face. Yeah? How do I get from smiley face, this leg, to the hypotenuse?
Smiley face times square root of 2.
Smiley face, square root of 2. Just a pattern, okay? There is only one scenario where it's not nice to you, okay? And this is going to happen a few times. So if this side is 4 square roots of 2, how big is this side? 4 square roots of 2. Now how do you get from a leg to a hypotenuse? Multiply this times the square root of 2. So I have to do 4 square roots of 2 times the square root of 2. Okay? So you can either remember this. What is the square root of 2 times the square root of 2? Too much. All right. 4, 2 times 2. 4. We get 4 square roots of 4. But what is the square root of 4? 2. So 2 times 4 is 2 times 4, 8. So look at the pattern. If you have a radical on the leg, the whole number will be on the hypotenuse. Remember I told you guys, what's 4 times 2? 8. Remember? You remember, Linda? Let's try it over here. What if this is 5 square roots of 2? How big is this piece going to be? 10. Because 5 times 2 is 10, right? We just did 5 square roots of 2 times the square root of 2. The square root of 2 times the square root of 2 is 2. 5 times 2 is 10. Like when you say the number 2 so many times in 20 minutes, it almost loses its meaning, right? The square root of 2, the square root of 2, the square root of 2. Okay, the only one that we haven't talked about yet is this guy. What if you have a radical on the hypotenuse? Yes, and there should be a whole number over here. So 6 square roots of 2 divided by the square root of 2. Don't make it hard. 6. And this one?
6.
Right? If the hypotenuse is 137 square roots of 2, how long is the leg? 137. And this leg? 137. Are y'all kind of picking up what I'm laying down here? So I'm going to give you guys all 4 scenarios. I'm going to put them all on one page, so maybe you want to snap a photo of them when I'm done, you can see it. Okay, 4 different scenarios. If I give you a leg can have a whole number, or a leg can have a radical. Okay, easy scenario, a little more complicated scenario. So remember the tricks. If there's a whole number here, what should be on the hypotenuse? A radical. And what's the only radical that we're using? Right? Now, if there's a radical on the leg, what should you expect to see on the hypotenuse? A whole number. 3 times 2 is... Not right now. Okay? So the first scenario, you see a whole number on the leg or a radical on the leg. The second scenario is you see a radical on the hypotenuse or a whole number on the hypotenuse. Okay? How do you get from a hypotenuse to a leg? Divide by the square root of 2. So if there's a radical here, there should be a whole number here. What falls off? Square root of 2 falls off. So 5 square roots of 2 divided by the square root of 2 is 5. Okay? If you have a whole number here, you should expect to see a radical on this side. So how do you make 10? Okay, so either multiplying or dividing. I'm just trying to show you guys some tricks. The absolute worst case scenario. That one sucks. Why does that one suck? It's an odd number. When it's an odd number, we still go back to how do you get from a hypotenuse to a leg? Multiplication or division. It's getting smaller. Divide. So I have to do 13 divided by the square root of 2. You're like, Baker, we've already done that, right? But we haven't done it with an odd number. So if I multiply by the number 1, 13 times the square root of 2. The square root of 2 times the square root of 2. And that's your answer. Throw up noise. Look at that nasty answer. 13 square root of 2 divided by 2. I can't say it's 6.5 square root of 2. I'm not allowed to have any decimals. So that means that this side length is 13 square root of 2 over 2. That's gross. Guys, the more we learn how to do this today, the better Monday is going to be next week. Alright, so let's try these problems. If we can do these, I will leave you guys alone. If this side's 5, how big is this side? How do I get from a leg to a hypotenuse? So I need to do 5 times the square root of 2. What is 5 times the square root of 2? Success. If this was a quiz, you'd have at least 25 points right now. Okay? If this side's 7, how do you get to this side? Okay? How do you get from a leg to a hypotenuse? What is 7 times the square root of 2? Okay, we good? Got a 50. If this side's 14, how big is this side? How do you get from a leg to a hypotenuse? 14 times the square root of 2. Okay, you got a 75. And there's always that one that always wrecks you guys. If this is 8 square root of 2, how big is this one? How do you get from a leg to a hypotenuse? Remember, that's kind of weird, right? What is the square root of 2 times the square root of 2? Is 2. And then 8 times 2 is 16. So if you remember the tricks, you just do 8 times 2 and you get 16 up there. Or you can do it the long way and it still works. So those are all legs. Now we got some hypotenuses. What? If this is 10 square root of 2, how big is this one? How do you get from a leg to a hypotenuse? So 10 square root of 2 times square root of 2 is 20, because the square root of 2 times the square root of 2 is 2, and 10 times 2 is 20. Now we're going backwards. Backwards saws. How do you get from a hypotenuse to a leg? You divide by the square root of 2. So 12 square roots of 2 divided by the square root of 2, those cancel each other out. So this is... Do you have to show your work for this stuff? No. Was that too much, or are we good? We only got 10 more slides. How do you get from here to here? Can't do that. We have to multiply it by 1. 2 times the square root of 2. the square root of 2 times the square root of 2. It's weird, right? But is it, what if I did this? What's 1 times 2? It's not that weird. It's kind of weird, but it's not. If you have a whole number here, you have to expect to see a radical over here. So how big is this one? If you have radicals here, you should expect to see a whole number here. So 8. I think I'm done. Because this is what we're going to pick up Monday. Now, is this a 45, 45, 90? It's a 30, 60, 90. It has its own set of rules. So I gave you guys a little bit of a worksheet there. I didn't give you a lot of time to work on it. So if you can just kind of practice some of those on that CUDA thing. I don't want you to do all of it. How many are there? 19. 19. You ever feel like you just can't even? You feel kind of odd, like I just can't even. Feel a little odd today, so let's just do odds only. You know, Colin did all of them already, right?
Yeah.
But he got all the
I just
practice.
did half of
You're good. So I'll just make it do half of it. You can do the first half, the last half, the even half, the odd half, whatever half makes you happy. Or you can do all of it. What doesn't matter. What's going to happen on Monday is we're just going to do a small piece of writing about these triangles. Just a little small piece of writing about these triangles. A little bit. Okay? And then we'll move on to the 30, 60, 90 stuff. Or scratch that. Monday we're taking a quiz. Nope, never mind. Taking a quiz on Tuesday. Your quiz on Tuesday will be 1 or 2 Pythagorean theorem questions, 2 45, 45, 90 questions, and 2 30, 60, 90 questions. That's 6 questions long. And it's open notes, like all the quizzes are. Oh, and I'm still recording all this.